So let's look at a few problems, very analogous to the book problems that you're going to be doing on the unit circle. We discovered some stuff about circles and points on circles today in class, but we were, kind of feeling our way. So here's something that's a little bit more regimented, perhaps. Remember the equation. We've got some algebra that can help us. If we've got coordinates, to be on the unit circle means that it satisfies x squared plus y squared equals 1. So for example, here's a problem. Show that the point, let's say, minus 5/7, I'm just pulling this out of the book, minus 2 root 6 over 7 is on the unit circle. It's not saying, not claiming you would come up with this on your own, but it's just a check. If somebody says this is on the unit circle, how would you check? Well, it's very straightforward. You can just plug it in. So we plug that in. We take minus 5/7, we square it, and we add that to minus 2 root 6 over 7 squared. Okay, so what do we get? Well, the minuses go away, which is pretty important, and we get 25 over 49 plus, now the other one has a denominator of 49 as well, which is nice, so it's already going to be a common denominator. Now 2 root 6 squared is 4, which is the 2 squared, times 6. Oh, okay, I can just do that. 24. Hey, look, that's 49 over 49, which is equal to 1. Now, a little harder is going to be kind of not going backwards like this, checking an answer, but actually getting an answer from the start. But that's a good warm-up, and it's very on the algebraic side. Notice I didn't even actually draw a picture, although I could. Let's actually just go ahead and figure out what this is. Okay. Minus 0.7, minus 0.7, roughly. They're very similar to each other, but not quite the same. So that means if I put it on the unit circle, it's in the third quadrant where they're both negative, and right about where they're both equal, minus about 0.7, 0.7. Okay, so somewhere around, right around here, just to be roughly correct. Okay, and we could even draw the radius that connects that to the center to get an idea of what happens. Like we could compare that to our standard radius and think that's a rotation from here around to here in the positive, that is the counterclockwise direction. Okay, so what about another kind of problem? Suppose we have a point P with coordinates, let's say 5/12, comma something, and we know it's in, well, it could be in the first quadrant with a positive x coordinate, or it could be in the fourth quadrant. Let's say it's in the fourth quadrant. Then what is the question mark? What is the actual point? Can we determine that? Well, yeah, we can. Again, we can do it with algebra. We know that x squared plus y squared equals 1, and x is given, so 5/12 squared plus y squared equals 1. And so this is how we come up with stuff like this. We can pick something here, and then we can see what y is going to turn out to be. Let's see. Here, the y value had a square root in it. We're going to discover that this one's actually nicer, and it actually won't be too much of a surprise. Y squared equals 1 minus, let's go ahead and square that, 25 over 144, or in other words, oh, sorry. Oh, I should have. Let's change this. I'm sorry. I'm just not thinking today. I want to make this work out nicely, and I'm just being clueless. Okay, that's what you get to do when you're the teacher. You get to change the problem to make it work out nicely. Let's suppose it was 5/13. I'm just rushing a little bit. Okay, so there's y squared, and the nice thing here is that this turns into a perfect square on top and bottom. And so if that's y squared, then y is going to be, now that's going to be plus or minus. Very important, that's the plus or minus 12/13. From the algebra, we don't know whether it's plus or minus. But we know it's in the fourth quadrant. That's where y is negative. And so we can say that's going to be minus 12/13. So that's going to show up down. So 5/13 is a little less than half, a little more than a third, positive. So somewhere around in here, the x-coordinate and then the y-coordinate is down here, pretty close to -1, minus 12/13. So it's going to be something like, well, I'll just draw the whole segment. So I'm just freehanding it, something like down here. Okay. And so that's that point. And we had to have that quadrant information. That's going to come back to us over and over and over again, that we have to have that quadrant information. Let's see. That's pretty similar to those guys. So now, what if we give the angle? This is what the book in section 5.1 calls the t value. I don't know why they do that, but it's the angle in radians. We could do it in degrees as well. We want to get used to radians. Okay, what if we give the angle in radians? Well, that can be pretty tricky unless we have certain special values. But one example would be if t, or that's really the same thing as theta. They separate that out in this book for some reason. What if that's, let's give a simple one to start. Suppose that's pi over 3. Okay, pi over 3. How much of a circle is that? Well, that is 1/6 of 2 pi. So it's 1/6 of the way around the circle. Let's see if we can figure out the picture for that. Well, 1/2 the way around the circle is like this, and it's 1/3 of that to make a 6. So it's somewhere up here. We can also convert it to degrees. We want to get used to working without having to go to degrees all the time. But it's also pi over 3 times 180 over pi, the conversion factor. And so that's 60 degrees. Oh, and I should put a degrees here too. Okay, so it's a 60-degree angle, which we're definitely more familiar with, and it's 1/6 of a circle. And so roughly, again, I'll just freehand it, it's up here somewhere. Okay. Alrighty. So that's, well, I'd like to know the exact coordinates of that point. And that's one of the things we figured out in class, that this is a special angle, comes from a special triangle. We can use our ratios, the 30, 60, 90 ratios for the 30, 60, 90 triangle. If we go back to the picture, we've got a 30, 60, 90 triangle here, or a 30, 60, 90 triangle here. We can use either one. And we get these ratios that we're going to memorize, and I'm going to quiz you on, that x, y is equal to, the x is equal to 1/2, and the y is equal to √3 over 2. Now, what about an angle that's related to that? What about t, or same thing as theta, equals, let's say, 2 pi over 3. 2 pi over 3. Where is that going to be? So I take this 60-degree angle, and I go twice that. That's going to end up over here somewhere. Well, another way to think about it is that I could take 1 pi over 3, 2 pi over 3, 3 pi over 3 would end up over here. Well, let's subtract off pi over 3. That's going to come back up this circle as much as this guy went over here. So it's going to just be the reflection of this point. So let's draw that. Let's just freehand it. Okay. Somewhere about here. And let's look at what happens. The x-coordinate is going to be negative of the x-coordinate for the previous one, and the y-coordinate is going to be the same. And so a lot of these numbers show up over and over and over again. So here, we're just going to take this guy, and all we have to do is change this to a negative. And so a lot of these magic numbers, like the √3/2, appear over and over and over again. That's a great place to stop.